Hello, everyone, and welcome to the Ask the Expert webinar, Executing SaaS Analytics from R Shiny Applications. My name is Tiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenter, Samuel Hawk, a senior data scientist here at SAS. Samuel works with the SAS Life Sciences Customer Advisory Team. In this role, he supports a wide range of initiatives related to data engineering, advanced analytics, AI and machine learning, real-world data, and open source. Working closely with epidemiologists and molecular biologists, Samuel develops computational workflows that facilitate rapid decision-making based on clinical and real-world data. He holds a PhD and has an active interest in the operationalization of analytics to improve speed to insight. With all of that out of the way, why don't we turn things over to our presenter so we can get started. Samuel, please take it away.
Yeah, thank you, Tiago. Welcome everyone today to this webinar, and hopefully we'll all learn something new. As the title says, we are going to talk about how you can execute SaaS analytics from R Shiny application, but the main focus would be R and SaaS integration, right? Okay. Just I want to discuss some scenarios that I have faced over my time here at SAS, and some of these scenarios comes from our customers, right? And oftentimes we see there is a data science teams that primarily working on R, but they also wants to leverage SAS macro libraries which are validated, right? Or a SAS developer develops some macros and the R programmer wants to use it, right? We often see that our programmers who are biostatisticians, yes, they love many R packages, but at the same time, they want to use SAS procs like ProcMix, right? Which are kind of the best in class in the industry, right? If you're doing mixed modeling, you want to use ProcMix, right? So that's a very common use case we have seen. If you're coming from life sciences industry, probably you're familiar with SDTM and ADAM automation. And what we are seeing, the trend is the data scientists develop this R Shiny app where they are trying to streamline their SDTM and ADAM automation processes, right? So how they can trigger this automation with a click of a button so that you can run the underlying SaaS workflows, but your front end would be R Shiny, right? We also see in the real world side of the world, right? Like the health economics outcome research team or HEOR team, they often leverage R for cohort analysis, but then once they get the cohort, they want to seamlessly execute downstream analysis that is written in SAS program, right? So how we can bridge the gap and make it part of a singular workflow rather than a data transfer from R to SAS and vice versa, which requires a lot of manual intervention, right? And as you see, similar example, like machine learning team wants to build an automated cohort building process, right? And they may have a R or Python front end. And then if you have a defined SAS job that you want to run from a dashboard, right? That dashboard you may have developed through R, right? And you oftentimes see me talking about Python as well, because the same concept applies to Python as well. This webinar is focused primarily on R. Maybe in another day, we'll discuss about Python, but what you can do with R Shiny, you can also do it with Python as well, okay? So before we jump into the detail, I also want to highlight the platform that we are using, right, for in this particular scenario is the SAS Viya, right? So that's the modern SAS platform. And from an end user perspective, I kind of see it this way. So in SAS Viya, you have programming interface. At the same time, you have self-service user interfaces, right? So if you're a programmer, you may just stick to the programming interface. So as a SAS developer, you can use SAS Studio Enterprise Guide or Visual Studio Code, right? And you can connect to Viya, right? And then if you're a Python or R developer, you can also interact with SAS Viya from your R Studio or Jupyter Notebook or other IDEs. Okay, at the same time, SAS Viya offers self-service user interfaces. So if you want to build a low-code, no-code dashboard, you can do it as well. You can build low-code model pipelines. So those are drag and drop interfaces that are also available, right? So today we are mostly going to focus on the programming side of Viya, how we can programmatically integrate R and SAS, okay? But one thing to keep in mind, under the hood, there is still the SAS engine, right? And in VIA, even though it's a one engine, but we kind of separate it in a way that there is in-memory processing capabilities, which is not available in traditional SAS 9 world, right? So you have in-memory processing engine, which we call Cloud Analytics Services, or CAS. So this is the high-performance distributed compute engine of VIA, right? At the same time, we have the compute engines, which is the traditional SAS 9 engine that many of you are already familiar with, right? So both are available to you. And then we can connect to different data sources, right? Leveraging SAS access engine and data connectors. So you have data access, and then you have your computational layer, and then you have your either IDE or your self-service user interfaces. Okay, that's how you interact with your data. And depending on your use cases, you can always load certain part of your data or the whole data into memory for high performance computing. Okay. So one key aspect of the new SAS platform is it's an API-driven architecture or API-first architecture. So whatever you do in this platform, there is a public API endpoint to it. And external interfaces or programming language or even softwares can leverage those public API endpoints. Okay. Leveraging those API endpoints, SAS has developed R and Python wrappers. Okay. So we have R and Python libraries called SWAT, which is SAS wrapper for analytic transfer. So SWAT allows you to directly communicate with our CAS or in-memory library. So if you have a data loaded in memory, you can leverage the SWAT packages. Okay, and then we have SASPy, right? So SASPy has been available for a while. It is also available for SAS 9.4, and also you can use it for VIA, right? And then you can leverage SASPy within R using a package called Reticulate, right? So that's a third-party package, and we'll discuss about it. You can also come from a Java client, and then we have SDK for JavaScript as well, right? So this API-first architectures allows end user to communicate with SAS VIA, right, from their preferred programming language or software stack. Okay. So when it comes to executing SAS scripts from R, right, because when you are thinking about integration between R Shiny and SAS, right? From the programming part, what you need to understand, how do we establish this connection between R and SAS, right? And here I kind of list with icons different ways. So one is RSWAT, right? So RSWAT, again, as a library developed by SAS, which will allow you to see and access the data that's loaded in memory in SAS VIA. Okay, that's one part. Then you can create SAS jobs, right? And those SAS jobs have public REST API endpoints. So you can leverage SAS jobs to call a SAS process directly from R, leveraging those REST API links. Okay, and then you can leverage SASPy with Reticulate, which will use a Python tunnel from R to use the existing SASPy mechanism and communicate with SAS. Okay, and then there are third-party packages that you can also leverage, and I mentioned here one package that is developed by Roche Genentech. It's called SASR, which basically wraps SASPy and Reticulate together. Okay, and here is a summary, and there is link to the documentation for each one of this method. And today we'll walk through some live demonstration to see how this can be achieved. Right? Again, to highlight, on the left column, you see the integration mechanism and who developed it. Right? So you can use SWAT REST API, you can use SASPy plus Reticulate, or you can choose to use something like SASR, right? And there could be other packages out there. SASR is, I mentioned here because I have used it. It's publicly available, and you can try it as well. Okay, so one of our first example, and we'll see a very short video. What is the end result that we expect to see? Okay, so as I hit next, you should be able to see a video in your media player. Okay. And here you can see an R Shiny application, right, which is called a SAS Data Viewer. And you see the end user coming in and selecting a in-memory table that's loaded in SAS, okay? And then you can create your preferred view, either through ggplot or other tools, and expose it to your RShiny app consumer, right? So this is the kind of thing you can expect to build, right? And you can see there is an scatter plot where you are plotting different variables. And then you see there is a run procfrig button, right? So what happens when you click on that button, it executes a SAS program, right? And you can also bring back the log if you want, and the ODS output to the front end, right? So this is a very simple example, but I hope you get the idea. So instead of run procfrig, it could be your own macro that you want to use. Okay. Moving forward, there is another mechanism to achieve the similar thing is leveraging REST API and SAS job execution. So what is a SAS job, right? So SAS job is very similar to SAS stored processes, if you're familiar with it. So Vaya comes with a SAS job execution web application, right? Where you can define a SAS job which have three parts. One is the program itself. So this is your typical SAS program. If you want, you can create a prompt on top of the program, but that is not required. And then you can add parameters to your program. So these parameters become macro variable to your SAS program. And this job, once you create a job, you get a unique job submit URI, right? And leveraging that URI, you can execute job from any external, either browser or a programming interface. Okay, so again, SAS job execution web application is a web-based client that used to create, manage, and execute jobs. And it comes with Vaya, right? So the moment you define a new job, you get a job execution URI. Okay, and how does it look? Again, we'll cover this in detail soon. But just to give you an idea, you'll have a SAS program, right? And it could be any type of program. And then you'll have some job parameters, okay? And some of these parameter can become macro variable within your program, right? And once you save this job, you get a job submit URL, right? So from your R program, then you can actually post to this URL to get back the desired result. Okay. One thing I must also mention, you can define how you want to ingest the output of the job. And here you can see we have defined, we want JSON output, right? And we are exporting the output as a JSON object, right? So when we query this URL, right, we get the result as an output, okay? Again, I'm forwarding to a very short video. So you'll be able to see the video in your media player. And then we'll see more details in the demo, right? So here you can see leveraging this URL, you can actually post to that URL from your R program, right? So that's the URL you get. And it's just calculating a means on a data set, right? And you can get back the result in your R instance, right? And then you can further work on that data, either in R or in SAS, however you want to. And at the same time, you can see you're also able to pass parameters, right, to your URL and get back the result. So job execution also provides a very flexible way to execute existing SAS processes directly from R. Okay. So now I think it's time for some live demo, and I'm going to share my screen at this point. Okay. Okay. I hope you can all see my screen. And here I am on my RStudio server. I'll also have my SAS Vaya instance open, and I may move back and forth just to understand what's happening on the R side and what's happening on the SAS side. Okay. So here you can see, first example would be how we can leverage SWOT. Okay. I just need to include this library, right? I need some certificates so that VAI understand I have the right permission and the right certificates to access the VAI environment. Okay, then there are many different ways you can do authentication. I'm using a very simplistic method here. But again, this is your choice as an R developer. How do you want to input the username and password? There are many, depending on what type of security you want, right? There are many different ways. And then I want to establish a session, right? So this would be a CAS session because we are only accessing with SWAT the in-memory datasets, right? So once I this on, you see that it's now connected, okay? And once it's connected, you can see I also have access to the libraries here on the right-hand side, but I can also print them programmatically, right? So if I'm looking at caslib info, I can list all the libraries, right? And if I go to my SASVA instance, right, here in manage data, right, these are all the libraries, right? And these are the in-memory tables loaded in the library, and I can see those here, right? But I'm actually seeing this data from my RStudio instance, right? So I can select a specific library. For example, I'm selecting the public library here, right? And then I am getting all the table information from the public library, right? And I can print, right? So these are the tables that is available to me in the public library, right? Again, just to confirm that you're seeing the same thing, if I click on this public library, you'll see those tables, right? Okay. And then I can also point to specific tables, you know, and just look at it, right? And one thing to understand, when I'm defining it as a CAS table, I'm not bringing in the table yet into our instance. I'm just reading the CAS table directly from R. Okay. If I want, I can also define it as a SAS table, as an R table as well. That option is also available. Okay. If I want, I can also load a table into memory, right? Using the load table action set. So that is also possible. So I have a SAS file called cars.sashdat, right, which is not loaded in memory. If I want, I can load it, right? So if I go to public, you'll see here, I have this public, it's in, just give me a minute. Yeah, so if I want, I can load this table into memory as well using this cars load table statement, okay? If I want, I can also fetch n number of rows, right? So there is a fetch action. So these are all SAS actions, but exposed as SWAT APIs, okay? So if I want to fetch, it will fetch first 20 rows of this stent failure table, okay? Can I move data from R to SAS? Yes, right? So I'm using empty cars, which is a sample R data frame, right? It's available to RStudio. And I can convert it to a SAS table, right? And this is just assigning it as from R table to SAS table, right? So I'll see empty cars underscore sh into the CAS user caslib, right? So if I now go to CAS users, right, you'll see that I have a table called empty cars underscore sh, right? So this is the same table that I moved from R to my SAS system, okay? And then if I want, I can also save it, right? So this is an in-memory table, but I want to make it persistent data, right? So I can save it as SAS7bdat, SASHdat, or CSV or Parquet, right? These are all the data types that by default supported by the SAS VIA platform, right? So if I go ahead and save it, it will create a Parquet version of the table, right? So if I go back again to CAS user, you'll see I have a Parquet file here, right? And you can see the timestamp, right? I just refreshed it, so it was written at 11:22 a.m., right? So this is the Parquet version of my data that we have seen. Okay, and you can also look at what are the files available to me, not just the table, right? So these are the underlying file that's available through this library, right? The CAS user library. And you can see there's a mix of SAS HDAT, SAS 7BDAT, and Parquet files. Okay. Okay, so this is one way to read and load data or save data leveraging the SWOT libraries. Now, if we want to run a machine learning models or something similar from R directly, right? Since I already have a session, I'm going to skip the first few lines, but I can again point to the public CASLib and see what are the tables available to me, right? And then I'm pointing to this table, SES cohort variable select. Right? So this is a cohort table, and we want to identify what are the most important variable for myocardial infarction. Okay. So again, you can see I'm using syntax that is very similar to R. What I'm defining here is what are my input variables, right? We know the 46 column is the target variable. So except from that, everything else is input variable. And then I'm defining here what is my target variable, and then we'll run a random forest decision tree like algorithm. I just need to load the right action set. And now you'll see this data, it is in SAS Viya, right? And I'm saying I need to run a random forest for variable ranking, okay? And you'll see that it runs within less than a second because it's leveraging SAS Viya's high performance computing engine, right? So this is a scenario where you may have a big data set, right? And then you want to really run some machine learning algorithm really fast, right? So you can get back the results very fast, and you can see here is the variable ranking, right? The variable importance ranking. And then we can save it within our R environment. Okay, so this is one use case where we often see you want to run some machine learning models on your big data. Maybe you don't have enough memory on R, and definitely in many R algorithms are single-threaded, right? So you can leverage the high performance computing of SAS Viya and get back the result in R. Okay. Okay. So this is leveraging SWOT. Okay. Now, if you just have SWOT, again, you can take the same concept, right? And you can take this into an R Shiny app, right? So when you build an R Shiny app, you'll have there are different ways, and this is not an R Shiny app webinar. Hopefully you know how to build one. This is a very simple example. So I have a UI definition and the server definition, right? So UI is how your front end looks like, what visual elements you want. And then on the server side, we'll establish all these similar SAS backend connections, right? And you can see here, as you've seen in the previous program, within the server, we are establishing our CAS connection. And then based on the event observation, right, we can leverage all these SWOT APIs to kind of read in the data, apply different actions on the data, right, and do your analytics, leveraging the SWOT API calls, right? So you can see once I run this app, and just to highlight, here I'm using a dummy user, right, user one. But again, in this case, username is hard-coded. There are many ways you can control this. But here you can see now the user can come in and select a specific CASLib, right? And within this CASLib, they can explore what are the data there, right? So I'm just going to look at the stent failure table, and then I can decide the number of bins, right? So this is a very simple R Shiny app examples. If you want to get started with SWOT and R Shiny, again, this will be available to you through GitHub. We'll share the link after this webinar. You can start from there. Okay. So once we show this, there are oftentimes I get a follow-up question, right? Okay, this is good, but this is for in-memory data, right? What if I have a base SAS or SAS 9 macro or program that I want to run, right? So there are two ways you can do that, right? So one example that we're going to show first is called SAS leveraging REST API. Okay, so let me go back to my SAS Studio. This is where we are going to leverage SAS job execution, right? As we described in our presentation, you can define a SAS job, and SAS job can contain a SAS program and some job parameters, right? So we are going to use this example called job underscore means, right? And this job definition has a SAS program, right, which is proc means, right? And this proc means just calculates the means of this SAS help.cars. And you can see here the by variable is a macro variable, right? So what it means, an end user can decide what would be their by variable, right? And on the right-hand side, we have these job parameters, right? So there are some systems parameter like context name, action, what output type you want, right? And then there are custom user-defined parameters. For example, this is byvar, right? And this byvar becomes a macro variable in our SAS program, right? And within these job properties, we have a job submit URL, right? So basically this URL, right? This is a public endpoint. And as long as I have authentication, right? I can take this URL and post to it, and that will start executing this job. And just to give you an example, I mean, I can copy this URL, I can paste it here, right? So what it does, as I have pasted it, it's starting a new SAS session and executing the job on the back end. You know, so as long as I have the access, right, that job will get executed and I'll get back the result. And you can see I'm getting back the result in JSON, right? So what we are going to do in our demonstration, we're going to do it programmatically, right, from RStudio, right? So you can think of if you have a existing SAS process or SAS macro, you can convert it to a SAS job, right? And this will give you a job submit URL. And you can programmatically post to that URL from your R Python interface, okay? You may ask, how do you create a new job? It's very similar to creating a new SAS program, right? So you can select a new SAS program, or you can say, I want to create a new job. And when you create a new job, click on new job definition. And in your job definition, you'll have your program, right? And then here you'll have parameters. You can always add new parameters, right? So once you save it, a job definition will be created, and you'll get a job submit URI after you save it. Okay. So going back to our main goal, how can you access or execute this job from your R interface, right? So once you define a job, the only thing that your R developer needs to know is this job submit URL, right? And definitely they need some authentication. Okay. So here is how we leverage the REST API call to integrate from with SAS from R, right? And I'm going to use two packages here. One is HTTR. This is for REST API calling, and then JSON Lite for parsing the JSON outputs that we are getting from our job. Okay. So again, it is going to ask me for my username and password, right? And then I'm pointing it to my via host. Okay. So just to give you an example, one key factor here is you need to have right authentication, right? So without authentication, if we just ping this via host, we'll get a 401 response, right? So that is access denied. Basically, we were not allowed to get any information out of that URL because we are not passing our credentials, right? So what we have to do, we have to create a header and body for the REST API request, right? And then we are able to post to get necessary access token. Okay. So here you'll see now we'll get a response from the VI interface. And in this response, SAS provided me a access token, right? And these access token can be used for any other downstream REST API call, right? So following on, we are going to use this access token. And now we are going to leverage that job submit URL, right? Just to remind, we received this job submit URL from our job definition, right? So again, going back to SAS Studio, this was my job submit URL, right? And I'm just using this URL within my RStudio, right? And again, you see, so if I post to this, now again, the process that goes on behind the scene, right? It start a new SAS session on my behalf, right? With the authentication based on the username and password that I have provided, right? And that SAS session would execute the job and bring back the result in JSON format, okay? And then we can parse this result and then print it, right? So basically from JSON, we are parsing it into a data frame. And as you can see, it calculated mean by origin. And now you may ask, why did it calculate mean by origin? We have not mentioned it here. So if I go back to my job again and go back to the parameters, here you see the by var has a default value origin. That means if the end user through their job submit URI are not providing a specific value for by var, the default would be origin. Okay. So now let us post to the same URI, but we'll add additional parameters, right? And you can see here, we are saying by var equals make, right? So using the same URI, but we are just appending this part, right? Ampersand by var equals make. So now the job would take in make as the by var macro variable or parameters, right? And this time, the means will be calculated by make instead of the default by origin. Okay. So once this is done, we can again parse the result, and you can see now its mean proc means was run by specific make instead of origin. Okay. So again, I hope this was clear. So this is another way you can trigger a existing SAS program from your R or RShiny interface by converting them to a SAS job. Okay, so this was one example. The next example would be, can we leverage third-party packages, right? As I mentioned, the third-party package that I'm going to demonstrate here is SASR, but it basically leverages SASPy, which is a Python package that is developed by SAS, right? And it leverages a Python tunnel from R, which basically goes through SASPy and connect to SAS via, right? So to use SASR, you need to also have a Python installation, right? So SASR is basically a wrapper of SASPy leveraging Reticulate. If you are comfortable with using SASPy and Reticulate, you may not need to use SASR. You can do it yourself, by yourself. Okay. So what I'm going to show here is how to leverage a package like SASR, right? And here we are also pointing to a specific Python installation. And here, when I ask to get a SAS session, right? What it's now doing, it's giving us a specific SAS session. And you can see SAS server started using SAS Studio Compute context. And we have a specific session ID, okay? And there is some error checking code. This is just I added to ensure that we actually have a session and we don't run into any error. And here you can see within this run SAS program, right? I'm just passing a proc freq to sashelp.hard, right? So I can paste my SAS program directly here, right? And then the result, I can get back the log. So here is your SAS log in text format, you can see, right? And then you can also get back the result, right? So you can see the result listing, right? So this is kind of the ODS output in text. You can also get an HTML output as well. So you can define how do you want to get it, right? So under the hood, SAS are using all the functionalities available through SAS-Pi. So if any API is available through SAS-Pi, you can access it from this my_SAS session object, and I can show you if I type it here, it has all these functionalities, and all these functionalities comes from SAS-Pi, right? We are just getting a wrapper through Reticulate in the R interface. Okay. And through SAS-Pi, you can also copy a dataset to R. You can also, so in this example, you can see we are outputting something named freq count within the SAS work library, right? We can do that as well. And then this freq count we can bring back to our session, right? And here you can see this is the frequency count from work library. We are copying it back using the SD2DF. Again, this is a SAS-Pi method, SD2DF. We are converting it to SAS dataset to data frame, and we can print it in our R session. Similarly, we can upload from R to SAS compute session as well, right? So I'm uploading the empty cars, which is again a R data frame to SAS compute work library. Okay, so we can upload it, and you'll see some warning because indexed are not transferred over as columns, only actual columns are transferred. Empty cars has some indexing, but then once I upload it, I can run a SAS program, right, on this data set, basically. Okay. We are also able to see what are the data sets available within the work library. Okay, so here is the result that we got, and if you want, I can also print the results. So this is the result on the empty cars, right? And then if we want, we can also see the data sets available in a specific library, leveraging this as well, right? So you can see these are the tables or data sets available within the work library. Those are printed here. Okay. So again, SASR, this is specifically for useful if you are considering running base SAS, right? And you don't want to focus on REST API calling. You can use either this or Reticulate with SAS-Pi based on your preference. Okay, and then we can take this whole concept, right? Leveraging either SWAT and SASR or REST API, right? We can create a more comprehensive R-Shiny application, right? And again, you'll see both components here. My SAS session, I'm getting a SAS session. And then at the same time, I'm also getting a CAS or in-memory session as well, right? So we can mix and match all these things together, right? Again, within R-Shiny, you usually have two parts. One is the UI side, another is the server side, right? And then you can leverage all these API calls and packages to establish your workflow from R-Shiny, right? So once I start this run app, right? This is again another sample app, but it has some additional elements, okay? So I'm going to my CAS user library, and I can select any table again, and we have this histogram viewer. I also have a data viewer here, right? So you can see the data. Again, these are R widgets, right? R elements, and you can decide how you want to leverage those. But now, once I click this run proc freq, right? So what's happening on the server side of the R-Shiny app, right? I leverage SASR to run the proc freq on the selected data table, right? And once I run it, you can see I got the log here, and then I also have my ODS output as well. Okay, so let us go back to the server side, right? And you see we have this observe event for all these elements, right? Like showing data and just doing the histogram. And then when I click on the proc_freq, actually what's happening here is you can see I constructed a SAS code, right? Again, this is just string concatenation based on the variable that we captured from our code, right? And eventually I construct a valid proc_freq code, right? And you can do it however you want. There are many different ways to do that. And then we are just running the SAS, right? So in this case, I could also do a REST API call pointing to an existing SAS macro libraries, right? Or I could just do a %include and run a macro that already exists within your SAS environment, right? So this can be achieved in many different ways, okay? Again, we cannot go too much detail here. This code will be available to you through GitHub, and feel free to reach out to us again, right? We are happy to answer additional questions beyond today's Q&A, okay? So I'm going to stop my screen sharing here and jump to the summary and references, because I feel like that is where you'll find the most relevant information if you want to implement this on your own, right? First of all, I want to highlight, right, the key important part to understand here, the API endpoints, right? So once you have API endpoints, you can leverage the REST API directly or the wrappers themselves, right? So it kind of make the SAS platform truly language agnostic, you know? And then again, you have to consider as an R-Shiny developer, when do you really want to trigger a SAS macro, and when you are happy with just remaining within R environment, right? So there are certain scenarios, especially when it comes to validated processes, right? Our big data processing, we see where our customers tends to go to VIA or SAS, you know. And the complete documentation for all the APIs and packages is available on developer.sas.com. And I encourage you to visit that website. These samples that we have covered today are available in GitHub, and the link is embedded in the PowerPoint. And there was a paper that was presented at Pharmasag, which is again publicly available, that covers all this conceptual idea. With that, Thiago, I hand it back to you.
All right, Samuel. Now on to our first question here. Someone's asking, can you do this in SAS VIA for learners?
I have to follow up on that. So depending on if VIA for Learner admins provide you the right credentials, you should be able to. So I have not tried that myself. Right.
Okay. Another question here. Someone's asking, what is the minimum architecture you should have to execute? If you have R, then do you need SAS VIA?
Yeah, so I mean, if you want to run a SAS procedure, right, or SAS analytics or your SAS macro, then definitely you need SAS, right? Now, the question of SAS VIA, it depends, right? You are able to do base SAS integration with SAS_PY and SAS_R, right? But if you want to leverage the high performance in-memory compute engines and the advanced machine learning and additional algorithms that comes with VIA, you need to have VIA, right? So the examples that we have shown today, right, that requires VIA. If you only have SAS9, right, then you can do some of the things, right, leveraging SAS_PY and SAS_R.
Thank you. Someone's asking, are there any limitations to the amount of processing power available from SAS within a Shiny app?
There is no theoretical limitation when you deploy SAS VIA, right? So VIA could be deployed within your preferred cloud, right? So it could be the cloud you own, or it could be also SaaS hosted, right? So when it is deployed, the admins can decide how to scale it, right? So you are only limited to the deployment limitation, right? But again, it can be always scaled up and scaled back down, right? And it take a few minutes to do that, right? So it can always be redeployed. So based on your computational requirement, VIA can be scaled, right? So there is no limitation in terms of how your R infrastructure is, right? So it's kind of decoupled from that perspective.
Thank you. Another question here. What should I consider while downloading data from SaaS VIA to R?
Yes. Yeah. So when you are downloading the data, right, there are, I say one key consideration is, first of all, how large is your data, right? Because when you are downloading it, you don't want to hit the memory limit of your R instance, right? And it can happen. Specifically, the world I work with, real world data, right, where you could have healthcare claims data and other things. You really don't want to download all the data into your R instance, right? So data size, that would be one limitation. And also to keep in mind, if there is a API available where you can process the data in SaaS, you should do that, because when you transfer the data, it's of a lot of time, right? And that's a IO overhead that we always want to avoid as data scientists and data engineer. And another consideration is data security, right? Sometimes you may not be allowed, if you're doing it from your computer, even to download the data in your computer, right? So these are the two areas you need to consider.
Thank you. Someone's asking, for SSL Connect, which key do I need to use and where can I find the key?
Okay, so this key will be provided by your VIA admin, right? So contact your admin. They should be able to provide you the key and the certificate that's required.
Thank you. Another question here. Do I always need to manually enter my SaaS username and password?
No, there are multiple ways. Again, this can be found in SaaS documentation, SWOT documentation, and SaaS PI documentation. So whatever package you are using on the open source, there are multiple different ways. One of my favorite ways to use a auth.info file, which securely stores your username and password, right? So you don't even have to enter it.
Thank you. Someone's asking, can I upload CSV files from R to SaaS?
Yes, you can. And again, I think I was really quick when I was trying to cover this, and I'll just share my screen once again. Yes, this is one simple example how you upload your CSV file, right? So one way is to leverage the upload.file API, right? And this is pointing to this particular CSV and pushing it to a library. And then you can also use the read.csv, right? So there are multiple ways where you can, ways to push CSV or other SaaS datasets into VIA. Back to you, Thiago.
Thank you. Another question, can you use desktop SaaS at all with the integration to R, or does it have to be online SaaS?
So I think what you mean is, does it need to be SaaS VIA or PC SaaS, if I'm understanding correctly, right? So with PC SaaS, again, you can use SaaS PI and SaaS R. There are some ways to do that, but again, there are lots of limitations. On the other hand, the SaaS VIA, which is cloud native, provides more flexibility, but it is possible, right? But there are limited options the way you do.
Thank you. I'm afraid that's all the time we have for questions today. If we did not get to yours, we will answer all unanswered questions in our follow-up communities post. Thank you, Samuel, for your answers, and thanks to all of you for joining us. On behalf of myself, Samuel, and all of SAS, we really hope that you enjoyed today's presentation. Thank you all, and have a great rest of your day.